Greetings and welcome to Chapter 10 of Digital Electronics. Arithmetic circuits, or arithmetic circuits, however you want to pronounce it. We talk with this one, we talk about binary addition, half and full adders, binary subtraction, half and full subtractors, parallel adders, blah, 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 blah. The biggest thing that's going to be most confusing about this aspect is going to be our 2's complement notation, but we'll have plenty of chance to get to that, and don't worry about it. We'll get there when we get there. All right, binary addition. Similarly, it's just like regular addition. It's just you only have 2 digits, 1s and 0s. 1 plus a 0 is going to equal a 1. 1 plus 1 is going to equal to 10. 0 plus 0 equals 0. It's really that simple. In this particular case, you got your 0 and 1. It's going to be 1. You got 1 and 0. It's going to be 10. So I got to carry that 1 there, and then like that, which gives me the same thing. Just showing it with the computer. Let's add these binary numbers. I'll throw mine down here. Got 0, 1, 1. 1 and 1 is 10, so there's 1, carry that 1. That gives me 1 and 1 is 10, so it gives me that. So it gives me 100110. Cool, okay. Now, a half adder only adds the LSD of a binary bit word. So let's say I've got 4 bits. It only adds this 1 bit here. That's all it deals with. It doesn't deal with these others. These others are dealt with something else. So we're going to have our input. This is a logical symbol. It's a half adder. Here's the sum. This is your output. Here's your input. Now the output's either going to be 1 or 0. It's that simple. And you're going to have a carry out. So basically, I'm going to have either 1 or 0 here, and a 1 or a 0 here, and it's going to add them together. If I have 0, 0, my sum's going to be 0, and my carry is going to be 0. So let's do a little truth table here. So 0, 0, 0, 1, 1, 0, 1, 1. And here would be my sum. Here would be my carry out. 0, 0 is going to have a sum of that with a 0 carry. 0, 1 is going to have a sum of 1 with 0 carry. A 1 and a 0 is going to have a sum of 1 with 0 carry. 1 and a 1 is going to have a 0 with a 1 carry. Now, this is just the way it looks with logic symbols for a half adder. So with 0, 0, our sum's going to be 0 with 0 carry. Right. If I have 0, 1, it's going to be 1 with 0 carry. If it's 1 and 1, it's going to be 0 with 1 carry. And another 1 and 0. There we go. Now we do a full adder. Excuse me. Full adder for everything other than the ones. So we go back to our diagram. This is handled by the half adder. The full adder handles the rest. Okay? Or specifically, we have a full adder for this one. We have a full adder for this one, and another full adder for here. So I'd have 1, 2, 3 full adders and a half adder. It's called a full adder because it accepts a carry in input. The half adder doesn't have the carry in. The full adder has a carry in. So I can add it, I can go from the next one to the next. Other than that, it works just like the other does. This is a full adder. So my carry in, if it's, 0, this acts just like a half adder. sum is 0. Since I've got 0, 0, carry out is 0. 0, 1 is, it's going to be 1 with 0 carry in. Carry in is 1, and I have a B. It's going to be a 1 carry out, because I have 1 and 1 is 0. The carry in gets treated like just another one being added in. Binary subtraction is the same way, except I'm borrowing instead of carrying. So 1 minus 1 is 0. 1 minus 0 is 1. Since I got a 0, I got to borrow the 1 from over here. It's going to leave me a 0, give me a 1. So let's subtract this one. 0 minus 1, or 10 minus 1, because I'm going to borrow that 1, leave me a 0. Well, now I got to borrow another 1, but there's not one to be borrowed from there. So that's going to leave that as a 1, and that goes away. It's going to go to 0. So I carried that one here, there, and then that's going to leave me with 1 minus a 0. So it's 1, 0, 1, 1, 1. Now, half subtractor is the logical half version of subtractor version of a half adder. It's the same thing. It functions the same way, all except you have a borrow out, which means I'm going to expect something to pull in from there. And you can go through this. Use a full subtractor. The same thing. The difference between the biggest difference, and some of you may have noticed it by now already, or you've looked ahead. Here's your full adder. I pull them in there like that. Got A's and B's coming in, and the results show up down here. Parallel adder. I got 1 1 0 0 plus 1 1 1. It'll give me 1 1 0 1 1. I'm missing something here. No. This is an IC that does the binary adder for full adder, for the 4-bit adder. You know, this thing to remember, 7483, and I believe we have one of those in our kit, and we'll do a lab with it. Work your way through these. Now, here's where we get to where I was headed. Now, if we're going to use a subtractor, it is really nothing more than an adder using inverters. Okay. Two's complements allows us to use the most significant bit as a sign bit. The rest of it's still the same. You know, so anytime you would see a 4-bit number with a sign bit, that tells you this is a negative number. Now what that means, since we only have 0, 0, 0 to 1, 1, 1, 1, that's 16 positions. Was it 8? Yeah, 16. 16 positions. That means we can only go from -7 to 8. If you think about that, it's 0, 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1. 0, 1, 2, 3, 4, 5, 6, 7. So 7 minus 8. There we go. I knew I'd get that right. Then the other way is 1, 1, 1, 1. It's minus 1, etc., etc. We'll get to that in a second. Right, number 4, convert it to binary, 0100. Make the 1's complement 1011, and add 1 to it, and now you have your 2's complement. Minus 7 to 2, there's 7. Add 1's complement, add 1, there's your minus 7. You don't need to do the 1's complement because you're already positive, so it doesn't matter at that point. Adding and subtracting as 2's complement is the same. You just make them 2's complement and add. And throw away the end. Yeah, you might want to invest in a good scientific calculator if you're going to do this a lot. And that does it for this one. Thank you very much. If you have any questions, feel free to ask. Get a hold of me. Be happy to work with you. Thank you. Have a good day. Bye now.